In this lesson, we're going to be talking about variables. Our lesson objectives include learning the assignment operator, learning the identifiers used in the Java programming language, and then applying said identifiers to the print statement. So we're going to be getting a concept that we learned in the previous section and applying it, or rather integrating it, into this lesson. The print statement, like I said, comes up a lot. So, variables. Variables you probably come across in your math class, such as solve for x or solve for y. But in computer science, a variable is a type of container that holds some type of value. And basically, when we declare a variable, what happens is that within our computer, the computer says, "Hey, let me get a piece of memory, like allocate a piece of memory within my PC, and store this variable that I want to have in there." And we utilize a specific name for that memory location. So that memory location within our program gets a name. And whenever we want to access it, we utilize that name to access that piece of data. So instead of saying x equals y in your math class, x could even be like a character, such as x equals c, or x equals hello world, or x equals true or false. These are just some types of data types that are included within variables within computer science. So the primitive types that we're going to be learning are integers, doubles, characters, and booleans. And then a non-primitive type that we utilize a lot are strings. So that's just important to note that strings are not a primitive type, but we utilize them just probably the same amount of times as we utilize the primitive types, maybe even more. Identifiers. Identifiers is basically any sequence of characters that name a variable, class, method, or parameter. So in our last lesson, we talked about the print statement, and when I was declaring the class, when I was creating the class, I called it the Hello World program, right? And when I even saved the Java file, I called it the Hello World program.java file. And this basically allows us to distinguish between different classes, different variables, different methods, or different parameters. And it gives it a sort of an identity. So if I want to access the Hello World program, I could just say I'm going to access the Hello World program. Whereas if we just had public class, right, the computer cannot distinguish between those two different classes because we didn't really name them. Same thing with variables. If we name just everything like integer or double, right, it doesn't, there's nothing to distinguish it. So we have identifiers to distinguish between different variables so that we have different memories that we can sort of access within our program. And it's important to note that they're case sensitive. So if I have a variable named Fozon with a capital F, and I have a variable name with a capital F, a lowercase f rather, these are not the same thing. In fact, we can probably name two variables with with the same characters, but not the same not the same lowercase or uppercase sequence. So Fozon here is actually very different from Fozon here. These are two different entities or two different identities. Whereas if we looked at it, right, it's the same thing, right? Usually the identifier should reflect the context of our variable. So when we're probably like listing out our identifier, right? And let's say if we want to store my name or if we want to store someone else's name, right? I think, or rather, most programs would agree that utilizing the name identifier is a lot of times better than utilizing just n for our identifier, because although n is kind of cute and pretty simple to program, it doesn't, you don't really get the context. You're like, wait, what is this n for? Whereas if I name my variable name, then we know, hey, there's probably a name stored here, or we're probably going to store a name in the future. So when we're naming our identifiers, or naming our variables rather, it should usually reflect the context of our variable. And traditionally, the first letter is lowercase. So this is just traditional. But when we have multiple words, the second word's first letter will usually be uppercase. But it has to be concatenated. It means that it has to be combined. So no spaces. We utilize the assignment operator to give a variable a value. The equal sign is used to assign the value to variable type. So the syntax that we use to actually create a variable or declare and then create a variable is variable type So we're going to put integer here, we're going to put double here, we're going to put boolean here, or string here, right? That is just going to tell, hey, we want this data type within our program, or rather within this piece of memory. And then identifier is the name that we have for our variable type. So that's just going to be our name equals value. And I know this might seem a bit weird as of right now, but I'll get to it more in depth starting now. So an example of a data type that I've already discussed are integers. And integers, as you know from math class, is a whole number, or any number that is not a fraction at all. And examples of integers are the number 5, the number 69, the negative 45,678. So the way that we declare an integer variable is we do int. Int is going to be our variable type. That's how we tell the computer, hey, the value that we want to store in our computer is an integer. Then we name it what we want. So our number is the name that we give this piece of variable. Equal, that's our assignment operator. We're telling the computer that the thing that's going to come after the assignment operator is going to be stored within the computer with this reference. And I have 420 as the stored value. So whenever we say, hey, can you print out our number, right? It's going to print out 420 because the computer's like, all right, let me find our number within my computer. All right, I found our number. Our number is equal to 420. So now 420 is the one that gets executed. Doubles. Doubles are basically integers, but they can hold decimals, right? So examples are 5.0, 69.9, negative 45,678.89. These are all doubles because they have a decimal component to it. And the Java syntax that we utilize for doubles is double, right? I don't think there's a shortened version for double, right? So we utilize double, then we name it. I just simply use the same value over that we used in the previous slide, but that won't work when we're actually making the program. But just for the simplicity's sake, this is going to be our identifier, and then we utilize the assignment operator to assign 420.96 to our number, and that means that whenever we access our number within the program, 420.96 will be the value that will be in the program. All right, Boolean is a different type of data type you probably not have come across in any other field such as mathematics. This value specifically can store a true or false value, and the examples that I put over here are true and false, and these are the only values that you can store in a Boolean variable. And you're probably wondering, why do we have true or false things to begin with? Later on within the course, I'm going to be discussing things such as if statements or control structures, or giving the computer a decision-making component, right? So where the computer has to decide, hey, if something is true, let's do this. If it's false, I need to do that, right? And this is where Boolean comes in clutch, because it allows us to give a decision-making component or a controlling component within the computer, within our program. And the Java syntax is going to be Boolean, my Boolean. That's my identifier that I called it because, I thought it would be cool. My Boolean, my boo, is equal to true. And that's really all to it. Now, if you want to make it false, you can make it false. That's how you declare it. Alrighty, characters. They can just store a letter or a symbol. Basically, it can store a character. It's literally self-explanatory. So examples are capital A, capital B, or lowercase c, right? Or you can store other characters that are probably on your keyboard right now, but you can only store one character. So the way that we declare it is char or car. Our character is equal to, then we have one quotation mark, then whatever we want the character to be, and then we have a close only one, basically an apostrophe, right? And then semicolon. And the reason why is because that specifies that we're storing a character, right? We can only have a character within those single quotes. Whereas when we utilize, say, a string is something that, again, it's a non-primitive type, but we utilize it a lot because it can store words and phrases, basically multiple characters. And the example is hello, Fozon is awesome, which is, by the way, true, a Boolean expression, and then nice. So the Java syntax for that will be string, my string being the identifier, and then we use double quotes because now we're specifying multiple characters. Fozon is cool, right? And then we would end with the semicolon that I did not include here, unfortunately. So that's how you declare a string variable. make sure that the double quotes are here, because that emphasizes that we have a string. Because if it doesn't, then it's going to resort to thinking that this is probably something that I should know, but when it really doesn't, because it's not really in the program, right? Foson, I don't think, is a programming keyword like public or static or void. Alrighty, so let's code. Okay, so I don't really want you to worry about this too much, but I already put the framework for our class and our main method. And the reason for this is because we are going to go more in depth into these concepts in a later section. However, I think it is very important for you to, at the moment, memorize that to make a class, it's public class, then you have the curly brackets and the closing brackets with the identifier of the name of our program. Usually it will reflect our lesson for the day. And then specifically want you to memorize public static void main string args. This is what we call the main method, and we're going to be utilizing the main method to execute the fundamentals of our programming or Java programming language. So we're going to be using the main method a lot to learn the fundamentals. So I don't want you to worry too much regarding the concept behind it. However, this is the framework that you have to get used to in learning in the future lessons. All right, so back to variables. The first variable that we're going to declare is an integer, and there's two ways to actually declare and assign a value to it. One is you do it all in one line, and the second way is, well, you do it in 2 lines. So I'm going to show you the two-line method, and then I'll show you the one-line method, and then you could be the judge of which way you want to do it. So to actually declare a variable, or an integer variable rather, right, we put int, just like in our PowerPoint, int. Then we have our name. So I'm going to name it my integer. Now we can name this whatever we want, but generally speaking, we utilize mainly characters, and we have the first letter of our identifier as lowercase. Alright, and then we put a semicolon. So this basically tells the computer to allocate a certain amount of memory for this variable. So now the variable actually exists, but there's no value that it is assigned to. So then we assign it using the assignment operator. So we're like, alright, my integer is equal to, let's say, 987. Alrighty, so now let's print out our integer. Now, if you remember from our previous video, what we utilized were double quotation marks. And the reason for that was because the reason why we did that was because we wanted to tell the computer that we were dealing with a string, or rather a series of characters that it probably wouldn't understand, because hello world isn't a variable name, nor is it like a keyword like public, static, or void. It's not something that the computer inherently knows. So this is something that it will print out. This is telling it that it's printing out a string. But our computer knows that my integer is a thing, right? Because it's a variable name and it's within our computer. It's a reference type. It's a reference. So the computer will be like, all right, find my integer, and then my integer is 987. So we don't need double quotation marks, and we shouldn't be utilizing it because it's not a string. It's a variable. Alrighty, so let's compile, and then let's run. Alright, and it prints out 987 because that is what the value that we assigned to it was. We can also do it all in one line. So let me eliminate this for now. And let's put a different number just so that we can see if it changed. So now my integer is assigned to 123. So it's declaring the variable, it's declaring that we need to allocate some memory, and then it's assigning it. And the number 123 is assigned to my integer. We can also change our integer later on. So let's say I want to name my integer 987 again. So what I'm going to do is, just to show you how it changes, I'm going to do my integer 987 we can re-access it. Do not redeclare it, because we're not redeclaring. My integer already exists, so we've already declared it. Now we're just reassigning it. You don't want to redeclare a variable, but you can reassign it. So I want you to guess what gets executed when we execute this program. Alrighty, so it prints out 123 because that is the value of my integer before the first print statement. And then after the first print statement, we reassign my integer to have 987. And then when we print it again, it prints out the new integer. Alright, so let's go on to doubles. So similarly with doubles, you can do it all in one line, or you could do it with a declaration, or you could just declare it on one line and then you can assign it in another. So I'm just going to name this pi because that's a double that I feel like we're all aware of. Wow, did I really mess up pi? Alrighty, so we've declared that we want a double and we named it pi. And then we set that pi equal to 3.14159. So when we print it out, it will be 3.14159. Now, to touch on why we shouldn't be using double quotation marks, it's just going to print out pi. So that's why we don't use double quotation marks, because it assumes that the identifier that we used here is no longer an identifier, it is now a string, so it prints out pi. So keep that in mind. Do not get tricked when it comes to those type of things. Alrighty, so then we have our Boolean, and I'm going to name it my Boolean, and it could be either true or false. That's the only two values that will work on here. And just like integers and doubles, we can reassign a value if we want to change it. So to show you how it changes, we can write a print statement twice. So we declare it, we assign it true, we print it out, then we're like, all right, I want to change it from true to false, right? And we don't redeclare Boolean because we already know my Boolean already exists and it already knows that it's a Boolean, but it is not true anymore. It's now false, and then it gets printed out. Alrighty, now let's do characters. Now with characters, right, it's just like a string, except, well, it's just one letter. And in that case, we only use one of these quotation marks. I would like to say apostrophe, but I don't think it's the right word. Alrighty, so system.out.println my car or char and it prints out A. Now let's see what happens when we accidentally put two quotation marks. Right, we get an error because incompatible, right? Because this is a string. When we use double quotation marks, we're telling it, hey, we want a string, not a character. So there is a big difference, so keep that in mind. Alright, so now let's make a string. String, let's rename it to my string, and then we could use the double quotation marks. So we could be like, alright, hello world. Actually, let's be like hello Fozon, because I like that better. Alrighty, let's change that back and put my string. And there you go. It prints out our statement. This 2 lines of code is actually equivalent to this line of code. So this basically accomplishes the same exact thing, but well, I forgot the exclamation point, so it might not be the exact same thing, but you get the point. But in this case, right, we first put a string, this is a string with double quotation marks, it's a string, into a reference that keeps a string. So it's in our memory now. It's saved on our PC or computer. And then we're telling the computer to find my string. So it's like, all right, let me find my string. And then my string is, oh, here, that's my string. And it's hello, Fozon. Whereas we just put the string within the print statement in the second print statement. And similarly, we can change the value if we want to, just like with all the other primitive types. So we don't have to reassign it. We just have to simply say, hey, let's reaccess that string and I want to change it. So now it's like, hello, user. And then I'm just going to simply copy and paste it. And boom. So what should we have? We should have hello world first being declared, or rather my string being first declared, and then hello Fozon being stored in that location. Then it prints it out. Then we get a reassigned string, and it says hello user within that location, and then we reaccess that variable, and it should print out hello user. And there you go. So that wraps up our lecture on variables. I hope that I hope I said it in much more simpler terms than I did in the presentation. And keep on practicing.